Welcome to Spanning Tree, a configuration adventure. This guide gives you information about Spanning Tree Protocol. Before Spanning Tree, there was no Spanning Tree. Restrictions for STP. An attempt to configure a device as the root device fails if the value necessary to be the root device is less than 1. If your network consists of devices that support and do not support the extended system ID, it is unlikely that the device with the extended system ID support will become the root device. The extended system ID increases the device priority value every time the VLAN number is greater than the priority of the connected devices running older software. The root device for each spanning tree instance should be a backbone or distribution device. Do not configure an access device as the spanning tree primary root. STP is a Layer 2 link management protocol that provides path redundancy while preventing loops in the network. For a Layer 2 Ethernet network to function properly, only one active path can exist between any two stations. Multiple active paths among end stations cause loops in the network. If a loop exists in the network, end stations might receive duplicate messages. Switches might also learn end station MAC addresses on multiple Layer 2 interfaces. These conditions result in an unstable network. Spanning tree operation is transparent to end stations, which cannot detect whether they are connected to a single LAN segment or a switched LAN of multiple segments. The STP uses a spanning tree algorithm to select one switch of a redundantly connected network as the root of the spanning tree. The algorithm calculates the best loop-free path through a switched Layer 2 network by assigning a role to each port based on the role of the port in the active topology. Root, a forwarding port elected for the spanning tree topology. Designated, a forwarding port elected for every switched LAN segment. Alternate, a blocked port providing an alternate path to the root bridge in the spanning tree. Backup, a blocked port in a loopback configuration. The switch that has all of its ports as the designated role or as the backup role is the root switch. The switch that has at least one of its ports in the designated role is called the designated switch. Spanning tree forces redundant data paths into a standby, blocked state. If a network segment in the spanning tree fails and a redundant path exists, the spanning tree algorithm recalculates the spanning tree topology and activates the standby path. Switches send and receive spanning tree frames, called Bridge Protocol Data Units, BPDUs, at regular intervals. The switches do not forward these frames but use them to construct a loop-free path. BPDUs contain information about the sending switch and its ports, including switch and MAC addresses, switch priority, port priority, and path cost. Spanning tree uses this information to elect the root switch and root port for the switched network and the root port and designated port for each switched segment. When two ports on a switch are part of a loop, the spanning tree port priority and path cost settings control which port is put in the forwarding state and which is put in the blocking state. The spanning tree port priority value represents the location of a port in the network topology and how well it is located to pass traffic. The path cost value represents the media speed. The default is for the switch to send keep alive messages, to detect local loopback conditions, only on interfaces that do not have small form factor pluggable, SFP, modules. You can use the no keep alive interface configuration command to change the default for an interface. The stable, active spanning tree topology of a switched network is controlled by these elements: the unique bridge ID, device priority and MAC address associated with each VLAN on each device. In a device stack, all devices use the same bridge ID for a given spanning tree instance. The spanning tree path cost to the root device, the port identifier, port priority and MAC address associated with each Layer 2 interface. When the devices in a network are powered up, each functions as the root device. Each device sends a configuration BPDU through all of its ports. The BPDUs communicate and compute the spanning tree topology. Each configuration BPDU contains this information. the unique bridge ID of the device that the sending device identifies as the root device, the spanning tree path cost to the root, the bridge ID of the sending device, message age, the identifier of the sending interface, values for the hello, forward delay, and max age protocol timers. When a device receives a configuration BPDU that contains superior information, lower bridge ID, lower path cost, and so forth, it stores the information for that port. If this BPDU is received on the root port of the device also forwards it with an updated message to all attached LANs for which it is the designated device. If a device receives a configuration BPDU that contains inferior information to that currently stored for that port, it discards the BPDU. If the device is a designated device for the LAN from which the inferior BPDU was received, it sends that LAN a BPDU containing the up-to-date information stored for that port. In this way, inferior information is discarded, and superior information is propagated on the network. A BPDU exchange results in these actions. One device in the network is elected as the root device, a logical center of the spanning tree topology in a switched network. For each VLAN, the device with the highest device priority, a lowest numerical priority value, is elected as the root device. If all devices are configured with the default priority, 32,768, the device with the lowest MAC address in the VLAN becomes the root device. The device priority value occupies the most significant bits of the bridge ID. A root port is selected for each device, except the root device. This port provides the best path, lowest cost, when the device forwards packets to the root device. The shortest distance to the root device is calculated for each device based on the path cost. A designated device for each LAN segment is selected. The designated device incurs the lowest path cost when forwarding packets from the LAN to the root device. The port through which the designated device is attached to the LAN is called the designated port. All paths that are not needed to reach the root device from anywhere in the switched network are placed in the spanning tree blocking mode. The IEEE 802.1d standard requires that each device has a unique bridge identifier, bridge ID, which controls the selection of the root device, because each VLAN is considered as a different logical bridge with PVST+ and rapid PVST+. The same device must have a different bridge ID for each configured VLAN. Each VLAN on the device has a unique 8-byte bridge ID. The two most significant bytes are used for the device priority, and the remaining 6 bytes are derived from the device MAC address. The 2 bytes previously used for the device priority are reallocated into a 4-bit priority value and a 12-bit extended system ID value equal to the VLAN ID. Spanning tree uses the extended system ID, the device priority, and the allocated spanning tree MAC address to make the bridge ID unique for each VLAN. Support for the extended system ID affects how you manually configure the root device, the secondary root device, and the device priority of a VLAN. For example, when you change the device priority value, you change the probability that the device will be elected as the root device. Configuring a higher value decreases the probability, a lower value increases the probability. If a loop occurs, spanning tree uses port priority when selecting an interface to put into the forwarding state. You can assign higher priority values, lower numerical values, to interfaces that you want selected first and lower priority values, higher numerical values, that you want selected last. If all interfaces have the same priority value, spanning tree puts the interface with the lowest interface number in the forwarding state and blocks the other interfaces. The spanning tree path cost default value is derived from the media speed of an interface. If a loop occurs, spanning tree uses cost when selecting an interface to put in the forwarding state. You can assign lower cost values to interfaces that you want selected first and higher cost values that you want selected last. If all interfaces have the same cost value, spanning tree puts the interface with the lowest interface number in the forwarding state and blocks the other interfaces. If your device is a member of a device stack, You must assign lower cost values to interfaces that you want selected first and higher cost values that you want selected last instead of adjusting its port priority. This marks the end of part 1.